Today we are going to learn how to write the equations for linear functions given the graph. When we do this, we usually only decide to put it into either point-slope form or slope-intercept form. So those are the two forms. We're going to ignore standard for today's video. So recall what the two forms are. Point-slope form is y minus the y value of 1 point equals the slope times x minus the x value of a point. So just to write it in this form, all you need to do is pick a point on the graph, an exact point. Substitute in your x1 and your y1 for those points, and then figure out the slope is and put that there. If you want to write it in slope-intercept form, you need to know the slope and the y-intercept. So once you figure that out, substitute in the value of the slope and the value of the y-intercept, and there you have it. We're going to do both for some of these. Alright, so here we have a line, and our goal is to write it in both point-slope form and slope-intercept form. Okay, so in order to figure out what the point-slope form equation is for this, we would need to pick a point on the graph. So we want to pick one that is very, very obviously a point on the graph. So why don't we choose, I don't know, this one looks like it's dead on right here. So why don't we use this guy right here, which is -2, 4. So we're going to use the point -2, 4. Okay, so it's going to be y minus the y value of this point, which is 4, so y minus 4 equals the slope. So let's find another point that looks dead on so we can figure out what the slope is. Let's see, this point right here looks pretty good. It looks like it's dead on. So the slope is that you go down 3, right 2, so that would be -3 halves. That's a negative sign right there. Okay, so there's your slope. And then x minus, the x value is -2 of that point that we used the 4 from. So the x minus -2 would be x plus 2. So there you have it. There's the point-slope form. Okay. Now, if I wanted you to write it in slope-intercept form, we need the slope and the y-intercept. So the slope shouldn't change. You pick any two points that look like they're exact on, and then you can do rise over run. So this is down 3, right 2. So y equals down 3, which is -3, right 2 is +2, x plus the y-intercept, and actually one of the points we chose happens to be the y-intercept. It looks like it crosses right on 1, so x plus 1. And there's the slope-intercept form of the equation. So both of these are equations for the lines. One's not more right than the other, they're just in different forms. We're used to seeing it in this form. We use this more often than not, but this is also acceptable. In fact, point-slope form becomes very important for for examples where the y-intercept is not right on a nice integer. You're going to see that in the next problem, which is the last problem. So let's take a look at that now. In point-slope form, we need a point and we need the slope. So let's pick a point that looks like it's dead on. I like this one right here, which is 2, 7. So let's write that down. 2, 7 is the point that we're going to use. So y minus 7, that's the value, is equal to the slope. What's the slope? Let's find another point that looks like it's dead on. This one right here looks really good. So the slope looks like it goes up 2 and right 3. So that would be up 2 is +2, right 3 is a +3, 2/3, x minus, and then your x value of that point that we chose is 2. Alright, so there it is in point-slope form. Slope-intercept form. The slope is no different. It's what we already figured out, 2/3. So 2/3 x plus, and where does this thing cross the y-axis? Ooh, look right there. That's not a nice spot where it's crossing. If you really look closely, you can see that it's slightly below 6, 5 point something. Okay, so what that means is we cannot estimate, we can't round, we don't want to guess. We really do need the y-intercept. So my suggestion would be one of two things. You can either keep this as b and then substitute in a point if you want to, or if you already have point-slope form figured out, you can actually solve this for y, and then you'd have it in y-intercept form. So let's do both. So first I'm going to solve this for y and then kind of reduce. So if I add 7 to both sides to isolate the y, it equals 2/3 x minus 2 plus 7. We then have to distribute the 2/3. Y equals, I don't know why that's there. Y equals 2/3 x minus 2/3 times 2 is 4/3, so 4/3 plus 7. Now we need to add these fractions together, this fraction, this whole number, so we'd have to make 7 into, in terms of thirds. So minus 4 thirds plus 7 is 21 thirds. And then we add negative 4 thirds and positive 21 thirds. We're going to end up getting y equals 2 thirds x plus 17 thirds. Okay, so now that's using point slope to figure out slope-intercept. All you do is you add the 7, distribute the slope, and then you'd have to combine these two constants together. Another way to do this, and this is the way that is probably more common in class, is if you want it in slope-intercept form, substitute in a value for y and x and solve for b. So let's take this point 2,7 and substitute it in. The y is 7, the x is 2, and we don't know b. So if we multiply 2 thirds by 2, we get 4 thirds. And then we'd have to subtract 4 thirds from both sides, or add negative 4 thirds from both sides. So 7 plus negative 4 thirds is equal to b. When we add it to this side, it just cancels out with the 4 thirds. We still need to do some conversion. So this is 21 thirds plus negative 4 thirds equals b. And then we end up still getting over here 17 thirds is equal to b, and then we would need to rewrite this as y equals 2 thirds x plus 17 thirds. We knew that it was 2 thirds was the slope. We were just trying to solve for b, so we substituted in a point, and then we solve for b. Either one of these things works. Point slope, I think, is a little bit more straightforward, but knowing how to solve for a variable in a linear equation like b or something else actually becomes very important later on in Algebra 2. So it's really good to know how to use both. You can either start in point slope and then get it into slope-intercept, or you can start with the slope of the line and then substitute in a point for x and y, solve for b, and then just replace the b with whatever you solved for it. Okay? So that's how you write the equation of a line in either point slope form or slope-intercept form.